Good morning, Lucas.
Nice to talk to you. Let's see. So I'm just gonna go read these. This look familiar? And yes, how's it all? One way of looking at it, you said one nice list of activities, and
Well, what does everybody wait for?
I thought
What does everybody want to do?
I'm not a professional on this at all. That would be what I hear from the first place. All right, you guys get over. I'll follow. I can talk for you. And then we get -9, right? That goes away. Right? Am I seeing this correctly? Yeah. Yeah. So you just write all these numbers without touching it, one? Oh, there is still currency. Oh, sorry. Oh, it's beautiful.
You and Eli, what? Running around the loop. What loop? Last night I asked you guys to change on the fly. It's really like round and round. You know, it's a very positive for us. So I know I just want to get down. Oh, yeah. All right.
9. And plug 0 in. 1.
Some amazing things for some teachers. I don't remember which. What? Somebody help that poems. So you notice here we just reorganized so the limit equal 1/6, and that's the right answer. Yeah. Sorry, Lucas. All right. So this you know is a precise definition of limit.
Yeah.
You have memorized. You know. And actually, I remember this. I know if I have a limit.
Yeah, you said you didn't memorize.
I don't memorize. I don't. I have an A and an L on some limit. And I'm going to use a line. Usually the lines. And I know for some plus or minus delta range, the results some plus or minus epsilon range. You guys agree? Delta faster. All right. All right. So I know then that if I take a look at this, if I say I'm looking for this range up here, it's going to be f of x, the value minus L is less than epsilon, so it's in that range whenever the bottom one is less than the delta range. Okay? And again, I'm not going to lie, a lot of students memorize this blue sentence. But if I plug it in, alright, and I start to simplify, and I quickly see this, I'm happy, and I can say the absolute value of x minus 1 is less than epsilon divided by 3. If x minus 1 is here, so we know by observation that these two numbers have to be the same because it's both less than. So delta equals epsilon over 3 in this case. So once we show a relationship between the x and y value, that shows that they're coming along the path, so thus find precise definition of limit, right? What do we know? We know the limit 1 of 3x
Yes.
plus 7 is 10.
Well, do you have to write equals 10? Or write 3x plus 7 minus 10?
You know, you gotta go back to the original.
Oh, you
Right,
right.
I'm
Okay.
proving that. I actually proved it. Show.
Then
Show or
same
prove.
thing.
And we proved it because we showed a relationship between delta and epsilon, between those ranges, 2, 4. Okay, second 2, 4.
Right.
That's the homework. All right,
So you can't change that thing at all.
no, you're proving that.
Even if you write it the same but different.
Right.
Okay.
That would be bad. Because this is one thing. Don't think of this, don't think you can break out this inside of this. This is one term. That's one thing. It's a value. Just like sine of 30 degrees. You can't divide by sine.
So you couldn't, I don't know, this might be silly, but I was just the limit of x as x equals 1 of 3x plus 7 minus 10, that'd be wrong.
Well, then you take equals 0, but we don't do that, right? Because this is this minus 10. This and this are not like terms. You can't make minus 3. Okay.
Okay.
You guys think you can show by IVT this function has a root?
Seems like a normal thing.
Alright, so listen. I say the function here is, I make this the function, right? And what the first thing we have to do to prove IVT is say, hey, f of x is continuous, right? Why? Because f of x is polynomial. Do you agree? So we make that declaration polynomial abbreviated. So then I'll check, does f of 0 is 3. I'll check f of 1, and I'll get negative 1. Do you guys agree? Alright, f of a and f of b are not equal. That's the second condition. So we're feeling pretty good about life. So in our heads, do we agree? It's a continuous function, and we just are picturing this. We don't have to graph this. This doesn't have to be on your paper. But you got 0, 3, you got 1, negative 1. And if the thing is continuous, I don't care where it goes through. Is there going to be a root? Absolutely, it has to be. We can't jump because it's continuous. So there's our at least 1. Could it be 10 roots? Could I have, could it be, well, that couldn't be 10 because it's a cubic, right? It could be 3. Well, we don't know, but we're just after, is there a root? Can we prove 1? All right. So we don't actually have that today. So now, is that all we have to show? Yeah. Thus, by what? Intermediate value theorem. There exists a C. And again, if it's close to this, it makes sense, right? Because you guys have learned that every time I write this, it comes out different, right? There exists a C such that C is between 0 and 1 this time, right? Where f of C equals 0. And maybe I go because f of 0 is less than f of, well, this time it's the other way. F of 0 is greater than f of C. Is greater than f of 1. It's decreasing function, you guys agree? It's going downhill. That's IVT. All right.